Today we're going to be talking about two types of balancing at our new balancing wall here at Victaulic headquarters. The first type of balancing we're going to be talking about is proportional balancing, which means getting enough flow at each terminal unit. The second type of balancing we're going to be talking about is pressure-independent balancing, or energy-efficient balancing. And to do that, I'm going to use our new balancing flow loop. On the flow loop, we have a variable speed pump that I can adjust the speed from a high range setting to a mid-range setting. We have a air separator with an expansion tank. We have 3 manual balancing valves and a differential pressure control valve. We have a ball balancing valve, an automatic balancing valve, and a pressure-independent balancing and control valve. Proportional balancing is getting enough flow at each terminal unit when the building is commissioned to achieve comfort at each room and to maintain proper room temperature at all times. There's a couple ways to do that. The first way is by using a quarter turn ball valve as a balancing valve. Because there's only 90 degrees to open, it may be difficult in order to get the proper set point that you want and get the proper flow that you actually want. On the left side, we have a manual balancing valve, which is a Y-pattern glow valve, which has 4 turns to open. You can see it's much easier to get the proper flow rate. We have a digital hand wheel setting so you can see the exact flow rate. And we even have a memory stop. So when the valve is set to the correct flow rate, you can close the memory stop and prevent the valve from being opened further than the set point. When you go to balance a building with manual balancing valves, you can start at one point, set it to, let's say, 1.5 GPM. Go to your second point, set that to 1.5 GPM, and go to your third point and set that to 1.5 GPM. What you'll notice, though, with manual balancing valves is that as I adjusted one valve, the others changed. So now I have to go and readjust the other 2 valves to get them to their proper flow rate. Also, when I have a pressure increase, when part of the building shuts down, I get an increase in flow rate at the manual balancing valves. And when there's a pressure decrease, I get it lower GPM. One other way to balance proportionally is with a automatic balancing valve. Now this valve comes preset to 4 3/4 GPM, so it's going to maintain 4 3/4 GPM at all times. You'll notice, though, that I do need more pump head with a automatic balancing valve, in this case 2 PSI. With a manual valve, I need 1 foot of pressure drop. So you can see that with this valve full open, I have well over 5 GPM, but I still need more pump head in order to get 4 3/4 GPM at the automatic valve. Once I have enough pressure, the valve will maintain a constant flow rate. The one issue, though, is with a modulating control valve. When the modulating control valve wants to close down to 3/4 closed, as the control valve closes down, the automatic valve opens up and overflows the control valve. Even when I get to 50% flow, you can see that this flow rate should be down at 2.5 GPM, but it's still up well above 4.5 GPM. Eventually the control valve will gain authority, but what you've done is you've turned a modulating control valve into an on-off control valve. Pressure-independent balancing means maintaining a designed flow rate at each terminal at all times. The first way that we do that is by using a differential pressure control valve. What this does is it takes a pressure signal from the inlet of the branch, and if there's a pressure spike, it closes down, and if there's a pressure decrease, it opens up. I have all these 3 manual balancing valves set at 1 GPM. I have our differential pressure control valve open and the bypass around it closed. What you'll notice when I increase the speed of the pump is that the terminal units will all stay relatively the same. So I'll increase the speed of my pump from a mid-range setting all the way to 4,800 RPMs. And you can see the flow rates increase for a moment and then maintain a constant 1 GPM. Not only will they maintain 1 GPM if I increase the pressure from outside of the branch, but even if I go and I close one of these valves off, they'll still maintain 1 GPM. What this is doing is providing energy efficient delta T back to the boiler or chiller and reducing your pump electricity usage by reducing the overall flow rate. The other way to maintain a constant flow rate and achieve pressure independence is by an all-in-one valve, our TBV CMP, which is a pressure independent balancing and control valve. This valve you can set to whatever flow rate you want, and it'll maintain that whether you change the speed of the pump or I change the load to other branches. So this valve combines the manual valve and the differential pressure control valve. The other new product that we have is our TBV CM valve, which is over here. This valve is similar to a manual valve. You can set it, you can read the flow rate, but once you're done commissioning the building, you can take the handle off and you can attach a modulating control valve actuator. And this now turns that manual balancing valve into a control valve. Same as any other 0 to 10, 2 to 20 modulating control valve that you would see out there. It has the same function on the TBV CMP. I can set the flow rate, then I can take the knob off and install an actuator to turn this balancing valve into a control valve. So your 3 different options for achieving pressure independence. First is an all-in-one valve, which combines a differential pressure controller, a manual balancing valve, and a control valve all in one. Your second option is to use a standard manual balancing valve and a modulating control valve with a differential pressure control valve. This differential pressure control valve can be used on multiple terminals, not just 3. And your third option would be to use a differential pressure control valve with our new balancing and control valve, our TBV CM line. So any option that you want, we have a way to achieve pressure independence.